if you have a perfect square trinomial, something like x plus 2 squared, that means you have to write it twice in FOIL, right? And so you get x squared plus 2x, and plus 2x would be plus 4x plus 4. If I gave you x minus 3 squared, what would you get when you multiply that out? X squared plus negative, or just minus 6x plus 9. Okay, if I gave you x plus 4 squared, what's that turn into? Okay, if I gave you x minus 5 squared, what does that turn into? Okay, so let's talk about the patterns here. All of these start out with an x squared. Now, if I gave you like 2x minus 1 squared, would it just be a 1x squared in the front? No. But because I started out with the 1x, we just get our x squared in the front. What decides whether this sign is positive or negative? This sign over here. Okay, how are these numbers related? The 10 and the 25.
That one's divided, that one's 25.
Okay. 5 squared is 25. 5 plus 5 is 10. Okay, so 4 squared is 16. 4 times 2 is 8. So if I started with an expression like this, if I gave you x squared minus 14x, could you tell me what this last number would have to be to make this a perfect square? How'd you get that?
Because 7 plus 7, or negative 7 plus negative 7 is negative 14, so its squared is 49.
Okay. So if you take these numbers, if I divided those by 2 and squared them, do I get the end? 4 divided by 2 is 2. 2 squared is 4. 6 divided by 2 is 3. 3 squared is 9. 14 divided by 2 is 7. 7 squared is 49. Okay, these are the perfect squares. So what we want to do is kind of use this knowledge to factor things that don't always factor nice. Okay, we were looking, not yesterday, the day before, at all these quadratics where box method was going to help us, where we would get an answer. But sometimes that doesn't work. So we have to make something that will factor. So what we're going to do is make a perfect square, something that follows this pattern, because then I could factor it into an x minus 7 squared or an x plus 5 squared. And we can break that down. So our steps, these are the steps that you wrote down on, I don't even know what day. Monday, thank you. Struggling today.
Yeah.
The first step, we will prefer this to be a 1x squared because it's just going to make everything easier. So if it's any other number, I want you to divide by it. So if I gave you like 4x squared, I want you to first divide by 4. If it was a negative 3x squared, you divide by negative 3. So first step, if you have a quadratic like this, we'll divide by that a if it isn't already a 1. Second step, what we want to do is keep the x's on one side and move the constant to the other. So we'll leave our a squared x and our bx over here. We're going to move the c to the other side. Then we are going to make a perfect square, just like we did right here. We're going to have something that looks like this. So you have to figure out what that other number is. So basically, if you divide this by 2 and square it, you get that constant term that we need. If you add it to one side of the equation, you have to do it on both sides. Then we can factor it. Then I could write this as an x. Will it be a plus or a minus? Minus 7 squared. And then we could do our square root method. Add square root to each side and finish off our solution. So that's the motivation behind what we're doing today. Any questions so far? This strategy can be done on any quadratic. Typically, you probably wouldn't do it if box method was an option because box method is a little bit faster. So usually we kind of reserve this for the things that don't factor nicely otherwise, but you could use it in any quadratic. So let's look at a problem. Could I factor this nicely? Is there anything that multiplies to negative 14 and adds to negative 4? No. So box method isn't even an option. So we're going to do complete and square. Step 1. If this is not a 1x squared, you have to divide by that coefficient. Do I need to? No. So I get to jump straight to step 2, which is move the constant to the other side. So I'm going to leave these. I'm going to leave myself a little space right there. To move your 14 over, you would add it. So it equals positive 14. Okay, next step. We have to make a perfect square. If this is a negative 4, what am I going to be adding here? 4. Basically what you do every time, you take this coefficient, which is negative 4, we're going to divide it by 2, and we're going to square it, because that's kind of the pattern we talked about. So negative 4 divided by 2 is negative 2. Negative 2 squared is positive 4. But it's an equation, so if you add it to one side, you add it to the other. Okay. At this point, we just created a perfect square right here. This should always factor into something squared. To factor that, the x squared would just break down into an x. There are lots of ways you could think about how to get this other number. First of all, do you know, will it be a positive or a negative? Negative. You could think, what's the square root of 4? 2. You could think, what's half of this term? Negative 2. You could think right here, when I divided by 2, I had negative 2. So there's a lot of different places you can look. You might just recognize it. If we had some uglier numbers, I just always tell people, look at what your number was before you squared it. This was a minus 2, so I'm going to have an x minus 2 here. Okay, over here this equals 18. Now this is like a problem we were solving on Monday. What would I do? If you include a square root, you also need, so this goes to x minus 2 equals plus or minus. Okay, can I break down the square root of 18? Square root of 9 is 3. Okay. Next step, we would add our 2 over. Can I just add this and make it 5 radical 2? No, they're not like terms. So your answer is 2 plus or minus 3 radical 2. But if you could add it. Yes. So if this were just like a 3 over here, you would do 2 plus 3 and 2 minus 3. Other questions? Because this one had a radical with it, so they weren't like terms.
Are any anything like that too? If there's any number like that, so any number that you add up there is going to be
Yes. Always just put it in front.
How would you get the 2 that we divided the 3
This 2 right here.
like the one to your right?
Oh, this. So our pattern is always going to be to take your coefficient on x, and I said square half of it. So you're always going to divide it by 2 and square, and that gives you that constant that you add to each side.
So we'll always divide that.
Yep, always divide by 2 and square. Other questions? do some more. Alright, what is my first step? Okay, we don't have to divide by anything because it's a 1x squared, so we add over the 2. So then, we have to make our perfect square. So, what am I doing with this? Okay. Now this is why I kind of wrote this out, because sometimes it's not as obvious. Negative 3 divided by 2 is not a nice number. I mean, it's negative 1.5, it's not horribly ugly. But I'm going to stick with the fractions. So if it doesn't divide evenly, just square your fractions. So negative 3 squared is 9, 2 squared is 4. So I'm going to add 9 over 4 to each side.
Are you always going to add that number?
Yes. When you square it, it turns positive, so we will always add it. Alright. At this point, we have a perfect square. So we can factor this into something squared. Alright, so for the first one, x squared, we know we're going to get an x. What is the other number in that parenthesis going to be? X minus 1.5, or I'm just going to stick with the 3/2. Easiest way, I've told you there's like 3 different ways you could get that number. The easiest way is really just to look at your parentheses. Before we squared, we had negative 3/2. So that's what's going to go there. 2 plus 9 over 4, 17 over 4. Next step. Square root. With that we do, so I get x minus 3/2 equals plus or minus. This right here is why I said to keep it in fractions versus decimals, because I do still expect you to break down radicals as much as you can. Can we do the square root of 17? No. Can you do the square root of 4? So it's radical 17 over 2.
Why isn't it 11? So we can just add the 2 to the 9.
It has to have a common denominator. This is like 2 over 1. So if you multiply by 4 on top and bottom, it's 8 over 4. Yes, ma'am.
Are we gonna get a 2 on the bottom?
No, as long as the radical's gone, you can leave it. Other questions right there? The 17, if it had any sort of expression, you would. Yes. So now we have to get the x by itself, so we add our 3/2. They're not like terms, so it's just 3/2 plus and minus radical 17 over 2. Okay, yes.
What if you go back using 3/2?
This number right here will always be the number before you square. So like on the previous one, negative 4 divided by 2 was negative 2. So negative 3 over 2 didn't reduce, so that's what I used right now. Other questions? Yes, ma'am.
So the x minus 3/2.
Mm-hmm. So it's basically always going to be multiple ways you can think about it. When we got our 9/4, I did that by doing -3 divided by 2 squared, so it's always going to be that number before you squared it. You could also just think this is a minus, so it's going to be a minus. Square root of 9/4 is 3 over 2. And that gives it also. Essentially what I'm doing is box method over here, but since it's always going to turn out to the same parentheses twice, I'm just writing it as something squared. Other questions?
This is a lot more complicated than the box method.
It is, but the box method wouldn't work here. If I try to come up with numbers that multiply -2 and add to -3, it doesn't work. So there are benefits to this method. It works for everything. Okay. Where do I need to begin here? Right. This one is not a 1x squared, so we do have to divide by 9 first. When you do that, you are dividing everything by 9, so both sides of the equation. So 9x squared divided by 9 is just x squared. 12 divided by 9, let's just reduce it. That would go to 4/3 x. 9 over 9 is 1. 0 over 9 is 0. Next step. Move your constant over, so subtract your 1. Now we have to make our perfect square. To do that, we always take this number divided by 2 and square. What is -4/3 divided by 2?
-2 over 3.
Okay. So if I square this, -2 squared is +4. 3 squared is 9. And you add that to both sides. Before I go to the next step, I want to know, does everybody know where I got my 4/9? Okay.
I did not get that one.
Other questions? Okay. So now we factor. This is going to factor the same every time. We have built a perfect square, so it will factor into something squared. We have an x. If you just look, before we squared, my number was -2/3, so it would be x minus 2/3. Okay. Right hand side, -1 plus 4 over 9. -5 minutes. To get rid of a square, square root, plus and minus. So I have x minus 2/3 equals plus and minus square root of -5. I radical 5. Square root of 9 is 3.
You pull the I out front.
You can put it out in front or off to the side, either way. Add your 2/3 over, so then you could write it as the I radical 5 over 3 or radical 5 over 3 with the I out to the side. It doesn't matter. Either way. Yes, Bill? Other questions? Let's do some more. Can I change this one? I want to make this a negative 8, I think. So 4x squared plus negative 8x equals 7. Yeah, or minus 8x, either way. I just wanted to alter my problem a little bit. I've done a lot of little subtraction. What would you do first? So we get x squared. Negative 8 divided by negative 4 is a positive 2. And then I have a negative 7 fourths. Step 2 is to move the constant to the other side. Do we have to do that?
No.
No, it's already there. So step 3, middle number, which is 2, divided by 2 and squared. So 2 divided by 2 is 1, and 1 squared is 1. So you add 1 to each side. So this will factor into something squared. Easiest way, we know it'll be an x. To get that number, look right here. 2 divided by 2 is positive 1. So this should be an x plus 1. Negative 7 fourths plus 1. Then we need to, and with that, so we get x plus 1 equals plus or minus. Square root of negative 3 is I radical 3. Square root of 4. And the next step, so it's just going to be negative 1 plus or minus I radical 3 over 2. You guys ready to try some on your own? Okay, I guess my lettering is off. This is really E. And I'm going to put another one up here. F is 3x squared plus 5x plus 1. Okay, so try these. So the first one, we have to first divide everything by negative 1. Add your 6 over. Sorry, subtract your 6. Now you do the middle term, so negative 11 divided by 2 squared. Doesn't come out evenly, so we're going to use a fraction. So it's 121 over 4. So this should factor into x. Think before you squared, it was negative 11 over 2. So it's x minus 11 over 2 squared. What's this? 97. Thank you. Square root plus and minus. So I have x minus 11 over 2 equals plus and minus. Alright, 97, any perfect squares go into that? No, so we're just going to leave it. Over 2. Final step, add. I do want to caution you, if that didn't have a radical, I would expect you to simplify further. So if it was just like 11 over 2 plus or minus 97 over 2, I would expect you to do the 11 over 2 plus that and then the 11 over 2 minus that. So if they are like terms, go ahead and simplify. All right, any questions there? Last? Yes.
We can do decimal, right, for 11 over 2?
Yeah.
I have the 5.5.
Yeah, it's okay. I prefer fractions just so we have, like, if one thing's a fraction, I prefer them both, but it's okay. Alright, this one, first step, divide everything by 3. So we get x squared plus 5/3 x plus 1/3 equals 0. Subtract over your 1/3. So middle term is 5/3 divided by 2 squared. 5/3 divided by 2 is 5/6. When you square that, you get okay, so this was a positive 5/6, so that means this is going to factor into x plus 5/6. Okay, this would be 1/3, is that right? Is that what you guys got? Let's see.
I got it.
No, it should be 13 over 36. Sorry. I was doing 13 over 26. Yeah, trying to read it. I don't know what I was thinking. Okay, so then right there, square root, plus and minus. So we get square root of 13, square root of 36 is 6. Subtract over your 5/6. Because of the radical, I can't combine them, but keep in mind if it didn't have a radical, I would want you to go ahead and simplify.
Are they ever not gonna have a radical?
Yeah, basically, if they don't have a radical, that means the original problem could have been factored with box method.
How can you tell? Like in the beginning, I guess if you could, like.
If you could do box method, yeah. Those are the ones that if you did complete the square, it wouldn't have radicals at either.
So you want to automatically find it about
I would recommend it. Now this homework assignment that I'm going to give you today, I would like for you to do completing the square on all of those just to practice it. But then in the future, if I just say solve it, box method would be my top option. So I would always try that. Then if it doesn't work, I would go to this. Okay. There is a math Excel assignment. It is 5 questions. It is not very long. So you've got some time to work now and ask questions if you need help.